Hello! In a previous lesson, we learned to take a rectangular equation and turn it into parametric. Today's lesson, we're going to take two parametric equations and turn it into one rectangular. Say, whoa. Whoa. Okay, I know that these are both parametric equations because it has x and y equals and they're in terms of t. If we want it to be rectangular, we want it to be y equals and then in terms of x. So here's my y equation. I need to replace t with x. So I'm going to use my x equation to see what t equals. So if I need to solve this for t, I would first need to add the 3, so x plus 3, and then divide by 3. So here is our value for t that I can now take and plug into t here for y. So for y, I'm going to say y equals 2 times t, but now we know that t is x plus 3 over 3, plus 1. So all we have left to do now is kind of simplify. So this would be 2/3 x plus 2 times 3 is 6. 6 over 3 is 2. Add the 2 and the 1. Here's our rectangular equation. Cool. So again, review. Solve for t, plug t into the y equation, simplify. We are now rectangular. Let's do the same thing over here for number 2. To get a value for t, all I have to do is subtract the 2. And now plug it into your y equation. So instead of t, we are going to be using x minus 2. We'll go ahead and expand this. So if I FOILed x minus 2 times x minus 2, you would get x squared minus 4x plus 4. Okay. Now, let's look at some problems that are more of our conics that we've learned. So either ellipse, hyperbola, parabola, circle, could be any of those. Because number 3 uses sine and cosine, we know that it is either going to be an ellipse or a circle. Secant and tangent is what is used for hyperbola. The way that we solve for x and y in the last lesson is to use that trig identity cosine squared plus sine squared equals 1. The difference between ellipse and circle is this number in front here. If it was a circle, these numbers are the same. If it's an ellipse, the numbers are different. So I know that number 3 here is going to be an ellipse. So let's review the way that we solved for ellipse. In our last lesson, when we solved for an ellipse, we took out the squareds, and then we set the x value to cosine, the y value to sine, and then solve for x and y. So what we're going to do now is just this same process backwards. So I need to take the problem that they gave me and solve for cosine t and sine t. So if I want cosine by itself here, I'm just going to divide x by 3. If you want sine, you are first going to add the 2 and then divide by the 4. So now putting these back into the trig identity, cosine squared plus sine squared equals 1, we will say x over 3 squared plus y plus 2 over 4 squared equals 1. Now redistribute that squared. X squared over 9, y plus 2 squared over 4, or nope, 16, equals 1. So there's the equation of our ellipse. So solve for cosine, solve for sine, put your x and y back into this cosine squared plus sine squared equals 1, distribute the squared. Cool. Okay, so now let's do this for hyperbola. Remember, hyperbola follows the trig identity, secant squared minus tangent squared equals 1. For ellipse, we knew x came first, so I didn't have to worry about exactly which order to write these. For hyperbola, whoever is with the secant comes first because we're following the trig identity. So let's solve for secant, solve for tangent. Secant, you're going to subtract the 3, divide by 4. Tangent, add the 2, divide by 3. And now we'll put these back into the trig identity, starting with secant. So x minus 3 over 4 squared. Remember, this identity has a minus. It's a hyperbola. Y plus 2 over 3 squared equals 1. Redistribute your squareds. And there is our hyperbola. Yay! So that's how we are going to be taking our two parametric equations and turning it back into one rectangular. So now let's talk about how to actually graph these parametric equations. When we have these new equations, we have 3 variables, x, y, and t now. Whenever you are graphing, you are going to be given an interval. For example, on number 1 here, our interval is 0 to 5. This interval is for our t value. So you'll have a t column from 0 to 5. Our job now is to solve for the x and y values given these specific t values. So for my x column, I'm going to plug 0 through 5 into the x equation. So 3 times 0 minus 3, negative 3. 3 times 1 minus 3, 0. 3 times 2 minus 3, 3. Okay, and continue all the way down. Okay, once you have the x column, we're going to do the same thing for y, but plug it into the y equation. So 2 times 0 plus 1, 2 times 1 plus 1, 2 times 2 plus 1. Now finish out the y column. Okay, so we have 2 parametric equations, but our graph is rectangular, meaning it's in terms of x and y. So I can only graph x and y. So these are the 6 points we are going to plot. The last point goes off our graph. So you might think, okay, I don't have to graph it. However, our interval says we need to include 0 to 5. So I'm going to include 0 to 5. So let's plot those points. Negative 3, 1, 0, 3, 3, 5, 6, 7, 9, 9, and then 12, 11 is probably here. So here's the graph of these parametric equations. So if we were doing a real-world scenario of these equations from 0 to 5, it would be this is what's happening from like 0 to 5 years or from 0 to 5 seconds. This is what's happening in terms of x and y. Let's do the same thing for number 2. We have some different problems. This problem got cut off. It should just say t squared. We are using the interval 0 to 4. So plug in these values for x, fill in the x column, plug in the values for t, fill in the t column. I don't feel like it's my job to teach you how to multiply, so I'm not going to go through this again. And now remember, even though we have 3 columns on our chart, you only use X and Y to plot. So 2, 0, 3, 1, 4, 4, 5, 9, 6, 16. We are not including any arrows on our graph because this says start at 0, end at 4. Don't go any further. Okay. I'm going to let y'all try number 3 and number 4. I will help you real quick on number 3. It's a little bit different. The interval is everything greater than 0. So what this means is you have to start at 0, but you can go to any points that you want. So this graph is going to have an arrow. When you are picking points to plug in for X and Y, you need to be a little strategic on this problem because for X, you're going to be taking a square root. So I can use 1 because I know the square root of 1 is 1, but I might not want to choose 2 because I don't really know the square root of 2 off the top of my head. So I'm going to choose numbers like 4, 9, 16, 25, numbers that are perfect squares so I can fill in my X column easily. Now remember, this last row might not be on your graph, but that's okay because you're just going to draw an arrow. So take 30 seconds, okay, maybe like a couple minutes, and solve number 3 and number 4. I want you to pause this video until you solve them and then play and you can check your answers. All right, did you get it? Yay! So for number 4, my interval, I went from -4 to 4, and then I knew the very middle would be 0. The middle of 0 and -4 is -2. The middle of 0 and +4 is +2. Fun. Okay, so now let's look at some more conic examples. Real quick, there's a mistake here. X, this should be cosine. Y, this should be sine. So we are given an interval 0 to pi because sine and cosine, we're going to look at the unit circle. So I'm going to kind of sketch a unit circle here so we can refer to her. We know this is 1, 0, 0, 1, -1, 0, 0, -1. So when I'm plugging in these values for t, I need to know, okay, the cosine of 0 is 1. The cosine of pi over 4, I know is out here, √2/2. Okay, so let's fill her in. So cosine of 0 is 1, but now we're doing 1 times 4, so that is 4. Cosine of pi over 4 is √2/2. We're going to be multiplying that times 4, so that is going to give us 2√2. We're going to be graphing this, so I'm going to evaluate that in my calculator to get 2.8. Okay, cosine of pi over 2 is 0. 0 times 4 is 0. 3 pi over 4 is -√2/2. We know times 4 is 2.8, so -2.8. Cosine of pi is -1. -1 times 4 is -4. Now let's do the same thing for the y value. So the sine. Sine of 0 is 0, times 4 is, times 4 is 0. Sine of pi over 4 is 2√2, square root of 2/2. Multiply it times 4, 2.8. Sine of pi over 2 is 1. 1 times 4 is 4. Over here at 3 pi over 4, this one's still positive, so we'll get a positive 2.8. And then sine of pi is 0. 0 times 4 is 4. So here's the points that we're plotting. So 4, 0, 2.8, 2.8, 0, 4, 2.8, 2.8, -4, 0. Did I write 4 here? Bizarre. Okay. So we got like half a circle here, which makes sense because I only went from 0 to pi. If I went 0 to 2 pi, I would have the full circle. For example, number 6 here. We want to go from 0 to 2 pi. Halfway would be pi. Between 0 and pi is pi over 2. Between pi and 2 pi is 3 pi over 2. So I want y'all to now try number 6. Pause the video and then check your answers. Is this what you got? Yay! Okay, so that is graphing parametrics. If you have any questions, ask your teacher. Bye!